you're going to see this screen. That's my default screen for any lecture I give these days, so I'll start from there. Okay, now one of my issues in teaching this is how do I teach neoclassical economics in particular? It's still the dominant paradigm, but obviously, and I'll show you talking through the lectures, there have been numerous logical and empirical fallacies as part of the theory. If you do a standard course, you won't hear any of them, as you probably realise when you're doing yours. Did you object to any of the lectures?
Yeah, many of them.
And what happened? They just give you a blank wall?
They just said, well, you know, we just carry on.
Yeah, exactly. They don't broach
no alternative.
They don't broach any criticism, do they? Now, of course, they've clearly had a huge paradigm contradicting event, which is the 2008 economic crisis. If their theory of capitalism was correct, such things couldn't happen. Okay? What they've really got is a theory of a stable system subject to exogenous shocks. To get a crisis that big, you've got to have an enormous exogenous shock. So far as I know, no meteors hit the planet in 2008 of big enough size to justify it, but that's still the explanation they're using. Then you have Marxian economics. Has anybody here read any Marx?
No.
Not much, okay. I've had a couple of very strong Marxists in my classes on occasions. I know them too, because there are core logical fallacies in what's called the transformation problem in Marx. Is anybody aware of what that term means, the transformation problem? You'll be copying a bit of mathematics on that when I go through the logic and the mathematics behind it. But also, of course, and then again, Marxists will object to this. They'll say the Soviet Union wasn't really socialist, etc., but nonetheless, you know, the vision that Marx had was a progression towards socialism, and that certainly fell apart with the collapse of the Soviet Union. The economic performance of the Soviet Union was not what was expected by Marxists, so that's another contradicting event. Then there's Post Keynesian economics. I call it a substantial minority paradigm. I would guess that about 1 in 10 academic economists is inclined that way. The reason I can give a number like that is that the French education system, which I don't know how similar it is to Austria, tell me if it's similar, but in France all academics register to being in a particular class of academic, whether that's physicist, chemist, economist and so on. So we know there are 1,800 registered economists in France, academic economists, and they get allocated it's not like you don't apply for a job somewhere, you apply for a job as an economist, then you will find yourself going to some particular university. It's very centralised. The group of economists, who of course includes some good friends of mine, formed what they call the Society of Appalled Economists, and they campaigned to have a separate division for their non-orthodox thought, because they said they were oppressed, they weren't given the right freedom to express their ideas by the mainstream. And of that 1,800, 300 people applied to join that new division. That's 1 in 6. That's pretty substantial. The neoclassicals think it's 1 in 100 or 1 in 1,000 who are non-orthodox and all the rest. They're wrong, empirically speaking, as usual. Their empirical knowledge is totally wrong. So it's a substantial minority paradigm, but it doesn't have a unifying theory of value. And what you get out of that is a more of an eclectic nature of the school of thought, which I think it has to really transcend to become a genuine school of thought. That puts me outside a lot of my colleagues who are happy to be eclectic. One of the main reasons I think you can't be eclectic and call yourself a school at the same time is that they're eclectic and they 100% reject neoclassical economics. And as some of the neoclassicals say, if it's horses for courses, why has the horse never got a neoclassical saddle? So in that sense, there is something unifying, though they simply haven't identified it properly yet. So it's underdeveloped and it's fragmented, but I think it's what I'm going to be focusing on as the alternative for you. You'll get just a few lectures from me on this subject, many more in the second half from the new lecturer who's turning up in January. And of course for them, the financial crisis was a paradigm confirming event, particularly for me, of course, but also Wynne Godley, dear departed Wynne Godley. And quite a number of other non-orthodox and post-Keynesian oriented economists were aware the crisis was coming. In fact, the funny thing is, you had to be an economist not to be aware that something was likely to happen, okay? Except for post-Keynesian economists. So I see both the neoclassical, and not Marx in general, but the standard way of interpreting Marx as a later theory of value, I see those as being paradigms in denial. They've failed, but the adherents are sticking to them in the same way that a religious group will continue to believe that there's going to be, behind some meteor there'll be a Ford pickup truck to coming to pick the 10 or so people who are going to be survived and the rest of us get exterminated, and every time the meteor doesn't arrive then it's going to be next month, etc., etc. Same sort of thing. It's more religion than anything else. So the post-Keynesian's viable, but it's incomplete. And I see two main things it needs. It needs a unifying theory of value, and it needs to adopt the methods which are common now in physical sciences of complex systems methods. And I'll be giving you some introduction to that. Who else is doing? Are you doing economic change and ideas? Okay, they'll be much heavier on that front than this particular subject will be. So if you look at the state of neoclassical economics after the crisis, it's clearly under attack, and this is probably my favourite attack article by Larry Elliott from The Guardian. And Larry came along, he actually chaired the event he's talking about here, because one of my many fellow critics of mainstream economics organised an event which was taking Martin Luther's, the anniversary of Martin Luther's nailing the theses on the door of the church, and used that as a satire. I dressed up as Martin Luther, and I was one of 4 people on the panel, and Larry was the chair. So Larry wrote this article the next day and saying orthodox economics behaves like the medieval church. It uses complex mathematics to mystify. You might as well be teaching in Latin. Did it feel like Latin to you occasionally? Yeah. And he sees it an unquestioned belief system. Anybody who criticises it is seen as dangerous heretics, and that's certainly me. And then he points about it can only be shown to work by making a series of highly questionable assumptions. What I'm going to be focusing on is this whole issue of what's the role of assumptions in economics. And he said when there's hard evidence that disputes it, they don't consider ditching the theory, etc., etc. Now the pushback to that is that you need simplifying assumptions. And that's what the neoclassicals came out. There's a place called the Institute for Fiscal Studies, IFS, which is a conservative UK think tank. And a group of them published this reply, Dismal Ignorance of the Dismal Science. And why do you have such a distorted view of economics? And they said the first answer is misunderstanding what mathematical models are used for and what you have to do to build a mathematical model. They say critics complain the models aren't realistic and make absurd assumptions. Well, so does the London Tube map. Yeah? If it didn't make absurd assumptions, it'd be illegible and useless. So you've got to scale it down. And that's their defence. We're using simplifying assumptions to remove the complicated stuff, cut through the undergrowth and be able to see the plain clearly, that sort of argument, or the mountains. So you abstract from unnecessary details. That's the defence they use. And that's what they say models are for, to help us find our way through complex data in a complex world. I must say I agree with the adjectives. Complex data, complex world. Not with their assumptions. So let's look at the London Tube map. Have you all got a copy? Pretty much. It works. What do you think of the London Underground? It's comprehensive but shitty machinery is my opinion of it. I'm living half time in Amsterdam these days, and the metro is nice and modern. What's the Austrian metro like?
It's amazing.
Pardon?
It's amazing.
Amazing, really modern.
Really modern, very... I mean, we do not have
something of the
this
scale.
many,
No. But what you have is a highly efficient, modern.
Yeah.
I think
Looks nicely, mostly.
much nicer. I think the British stuff is like a set of museum pieces that are still functioning. You almost imagine that the Winston Churchill's going to hop on at the next stop. It's so primitive, but it's huge, and that's the entire extent of it. And if you look at what it's doing, it's just the section around where I used to live in Waterloo. What it tells you which towns are on which line. So, Lambeth North is on the Bakerloo line and Southwark is on the Jubilee line. So there's Lambeth North, there's Southwark. It tells you the Westminster is north of Waterloo and Victoria is, I think I've got that right, is west. Okay, so the geography's correctly in a very stylised way. It gives you the geography. It tells you where the lines intersect. So if you want to go from Lambeth North to Southwark and you're too lazy to walk, it's only about, as it happens, that distance is about a kilometre. Okay. So you don't know that on the map. You have to know London, know it's 1 kilometre apart. But if you wanted to go by tube, that's how you do it. And it ignores topography, it ignores precise distance, it ignores roads. So it's leaving out details you don't need to know to use the map. So it's a classic example of simplifying assumptions, and that's how they defend themselves. Now, what about Ptolemy's epicycles? Does anybody know Ptolemy's theory of astronomy? Have you heard of epicycles before? Okay. If you go back to Aristotle, 2,500 years ago, Aristotle apparently considered two explanations for the motions that he saw in the universe. One is that the sun is the centre and we're spinning around it, but he ruled that out. Actually, Ptolemy did this. Ptolemy ruled it out because if it was the case that the sun was stationary, we were moving around it, the wind would be too high. So that couldn't be the explanation. Okay. So what he did instead was say, what must be the case is we are the centre of the universe, we are still, that's why there's, the winds aren't all that bad, okay, and the planets and the stars orbit us around us. But of course, to explain what the planets do, the planets actually appear to reverse direction. So what he had was everything's in perfect circles, almost centred on the Earth, not quite, and then everything revolves around it, and the stars aren't moving in this pattern, but the stars do revolve, if you see them from the Earth's point of view. Revolve on the Earth on the 24-hour cycle, but the planets reverse directions. What's actually going on? They're on the perfect circle called the equant, and the small ones they cycle on are called epicycles. And there's 2 or 3 other modifications that are made to make that particular theory work. And it was, though it slipped over time, over 1,500 years. The actual patterns changed all the time, and you had to work really, really hard to build a set of models of circles on circles that would reproduce the pattern you actually saw in the sky. But you could accurately say where Mars was going to be in 300 years. Okay, you could go back and forward in time and so on. So that's the assumptions that Ptolemy used to explain the motion that was observed in the universe. Do they look like simplifying assumptions to you? They're not, are they? Okay. They're assumptions that make an Earth-centric model appear to work, but they're complicating assumptions. If you actually look at how the planets move, this is what they do. Ignoring, of course, the motion of the sun itself. But they move on fairly simple patterns, elliptical orbits. That's what's actually going on. So Ptolemy's assumptions of circles on circles wasn't because it was simplifying. It was an assumption you needed to make a false paradigm work. I think the same thing applies to neoclassical assumptions. They're making what I call counterfactual or complicating assumptions to make an equilibrium barter model of capitalism appear to fit the data. And it worked, roughly speaking, until the financial crisis hit, and then they blew them out of the water. So let's take a look at some of the assumptions here, because one of the key ones is the idea that there's rising marginal costs. Now, who has done microeconomics at all? Who has not done any micro? Have you seen supply and demand curves? You know the idea of, you haven't seen them? Lucky girl, but nonetheless, I'll inflict them on you. So let's see if I don't have any. I never come with whiteboard pens. Does anybody have a whiteboard pen? Go back in my office. Anything possible? Damn. Okay. Imagine that. Okay. What they argue is you have, they say demand is, they will draw quantity sold on the horizontal axis and price on the vertical. And they'll show that as the price falls, more is demanded. So you get a downward sloping curve for the demand curve. And they say as the quantity sold increases, you get a rise. Thank you. You get a rising supply curve. So what I'm talking about now is the explanation you give for the rising supply curve. And I'll include more diagrams in next week's, because again, I was assuming a bit more knowledge than I should have done. So that's how they say the market is equilibrium. The equilibrium price gives you the amount being supplied is equal to the amount being demanded. And that's the logical argument they make about it, or appears to be logical. They're doing all sorts of things mathematically wrong, by the way, because they say quantity actually determines, or price determines quantity. Okay, that's the theory they have. Price determines the amount firms are willing to supply. It determines the amount consumers are willing to demand. So if a mathematician was drawing that diagram, they'd reverse the axes. They'd have price on the horizontal and quantity on the vertical. So they talk about what's called an inverse demand curve. For that reason, if you read the literature, you'll see them saying inverse demand function. That's because actually the way they've got them out, they've got them the wrong way around. It dates back to Alfred Marshall, who first dreamt it up. So the theory they have is something like this. They say many firms, like for example, Big Bob's Bagel Bin. This is a first year textbook. Big Bob's Bagel Bin. Increasing marginal cost before diminishing marginal product. Now cost curves that look like this. This is all an extract from the Mankiw textbook. So what you've got is this idea of here's your marginal cost. This is the total cost of producing output. So here's 1 unit being produced, and that costs cost of producing a total cost is 2.5 euro, let's say. Then 2 are produced for slightly less than 4, so the second one costs a bit less than the first. Then it flattens out. Then after you get about past 6 bagels, I think it's 6 bagels per hour. Ever been to a shop that sells 6 bagels an hour? That's a bankrupt shop. And then it increases, and the total cost continues rising at a steeper rate. So that's what they show as the alleged total cost of operation of this well-known firm called Bob's Bagel Bin. And then what they do is they divide the total cost by the actual number of units being sold to produce the graph down the bottom. And this is the key fiction that they have about the cost of firms. What they show is they break it down to what they call fixed costs, which are, you've got to build if you're going to make bagels, you've got to have an oven. It's actually fixed cost. And then the variable cost is how much dough you put through the oven, how many workers you hire to put the dough in the oven, etc., etc., and they call those variable costs. So if you have a look at the fixed cost, let's say the oven, in this particular case, looks like the oven costs $2. Get the point there? Notice here, this is just showing the numbers here. That's what's called average fixed cost, and that declines radically throughout the whole operation. So you're saying the fixed cost of the oven at $2. Anybody bought a bagel oven for $2 recently? Okay. This is child's play. This is treating adults as children to give stories like this. And there's one reason that I became very irritated by this stuff back in my first year at university. So the fixed cost, $2 per, give me a break, $2 for the fixed cost or something. And then of course for the second it falls to 1, and for the third it's 67 cents, etc., etc. So you get out to the 10th bagel, and the 10th bagel, the fixed cost of the 10th bagel is 20 cents. Okay. Now the variable costs, he's not saying what they are, but they'll be labour time and the amount of dough you've got to buy to put through it. And that has, those fixed costs, average variable costs, fall for a while, and then they start to rise. So the average variable cost of this curve here, and what you've got is the individual, each additional bagel is costing the change in the variable cost from one to the next. First of all, the change, the first one is $1, then it's 75 cents, then 50, then down to 25, and then it starts to rise. And you get this rising called marginal cost, and that's the cost of the additional bagel. So if you're producing, let's say, you're producing 10 bagels here. We come up here, that 10 bagels is costing about $11. The 12th bagel makes your total cost come up to about, it's about 13. So the marginal cost of the additional bagel is $2, etc., etc. And on they go. And that's a typical drawing from a first year economics textbook. So notice how trivial average fixed costs are in this model, and how high marginal costs are. And average fixed costs are falling because when you have a fixed cost, let's talk about a genuine factory, like a fixed cost of making a silicon chip. Okay, the minimum fixed cost for building a factory to build silicon chips in the sub-micron level is a couple of $1 billion. Okay, so a couple of $1 billion is your cost, and if you produce one chip, the fixed cost, average fixed cost of that one chip is $2 billion. And of course, they sell far more than that. You're buying them for effectively 50 cents each. So they're producing tens of millions of these chips over time. So that's your average fixed cost. They don't necessarily follow a rectangular hyperbola. But what they've got is variable costs average variable costs falling for a while and then rising. That's a typical belief system they have. Now, if we look at the real world, would that be the simplifying assumption we make about those firms? So let's look at some real world data. And what you see is you get we know this, we had an enormous range of shops, from a tiny corner shop, which would be making a lot more than 6 bagels an hour, but a small shop making bagels, to Amazon. You go from operations that have only one outlet to ones that have operations in virtually every country on the planet. And you have firms which produce a single product, like a wheat farm, to companies like Sony and LG that produce dozens of different sorts of products, covering one industry to many industries. Ownership goes from being a sole proprietor to a multinational listed in many, many countries. The structure, you have one person to multi-department or operations. You have others that specialise in manufacturing, retail, marketing, etc., etc. So, what neoclassical economics does is simplify that to 3 categories, predominantly, maybe 4. They talk about perfectly competitive markets. Markets where you're so small you can't affect the market price, and I'll talk a bit about the logic of that next week. What they call imperfectly competitive, where you're small but you can affect the market price. Oligopoly, where there's a few big firms competing, and a monopoly where there's just a single firm. That's pretty much the taxonomy that you'll get from neoclassical economics. Now, let's take a look at the stats. Here's data. I'll give you all every week I'll put the PowerPoint slides up, both on my website, which is the Patreon site, and on the university site, so you can access them there as well. So this is data you can get from America. It was up to date to last year, and it shows that there's an enormous range of firm sizes, from sole proprietors to firms employing millions of employees. And again, the same sort of thing, single product to diversified. And in 2014, the last year for which they had data when I checked it, there were 5 million firms. Now, can you divide them into that classification? Let's look at the sizes of them. Okay. Now, this tells you that with a firm size of between 1 and 4 employees, there's 2.8 million firms like that in America, and the average is 2 workers per firm. I've rounded all the numbers. Actually, I think it's 1.4 on average, so I've rounded just to integer values there. Right at the other extreme, you have firms with 10,000 or more employees. There's over 1,000 of them, and on average, they employ 24,000 workers each. Okay. And then look at the number of employees. Now, to have a look at that data, can you see anything curious about the data? Yeah.
But it doesn't rise substantially.
Yeah.
The number of employees.
Yeah, if you take a look at it, the number of people, and once you've got all these different firm sizes and totally different number of workers per firm, the total number in each of the bins is pretty much the same, isn't it? Now, that is not an accident. There's something very informative about that, and I'll show you that in a moment. Because let's now graph it. So I'm graphing on the horizontal axis. I've got the number of firms, starting from 0 up to the 2.8 million firms that I showed you, and there's the number of employees. Can you make any sense of that? Useless, isn't it? Let's use logs on both axes. Now that, when you see that, there's information there. Huge diversity of firm sizes, huge number of different firms. One simple statistic gives you an incredibly high correlation to explain to us. There's something behind the data. If you get I can do a simple regression plot, what you might have expected with your cloud of different firm sizes, different numbers of workers. The dots could have been all over the place. Why on earth are they almost on a straight line? Okay. There's something really interesting in that, which economists completely ignore. Okay. Most economists will not even know this data exists. Okay. What it's doing is following what's called a power law. Now, obviously, one nodding head here has seen the power laws before. And they're a strange, fascinating thing, which says that the number of something is a function of the size of something. So the number of earthquakes is a function of the scale of the earthquakes. There are very, very few earthquakes which hit 9 on the Richter scale. So far as we know, there have been 1, maybe 2 in recorded history. The one in Southeast Asia in 2007, I think it was, and the one in Portugal about in the 1700s. Most earthquakes are far, far smaller than that. Now, at the other extreme, there's millions of earthquakes with a Richter scale of 1 or 2. Okay. So that follows a power law. Now, the one we've got here is the number of workers per firm is roughly equal to a constant divided by the number of firms of a given size raised to a power, and that power is negative. So what you get is, if you take the constant is 7 million, and notice the numbers down here are all in the 7 million scale, divided by the number of firms raised to the power of minus 0.9 I'll multiply by the power I'll make it divided by the power of the number of firms to the power of 0.998, almost the power of 1 over. And what you then get is saying, well, if you imagine that if there were 10 million firms, there's not in America, only 3 million firms in the data. But if you said if there was one worker per firm, there'd be 10 million of them. If there's 2 workers per firm, there'd be 5 million of them, etc., etc. Right down to saying that there's 100,000 workers per firm, there'd be 153 firms like that. And look at the numbers. They're very similar to the numbers I showed you for the actual data. So there's something quite intriguing about that. Now, power laws, and so I gave the example of number of earthquakes given the size of earthquakes. The power law applies for that. Take a look on the web, you'll find it quite intriguing. I'm not going to go into detail on that here because we simply haven't got time. I'll cover maybe a bit more on the change in ideas, but it's a very fascinating element of how we should be analysing economic data, and it is done by physicists and even linguists in other areas. In fact, the frequency of words in prose comes down to a power law distribution. What's called the Ziff law is where that was first found. The number of followers people have on Twitter and Facebook. And what's going on, it's an interaction between entities. It's not something which comes out of isolating one firm from another. There's something about the interaction of firms that gives you this huge scale. So we should be looking about a dynamic process by which firms grow and shrink and compete with each other and occupy different niches and so on. It's an evolutionary thing. Now, as it happens, given that data, you cannot work out a representative firm. Just notice the fact that all the number of workers per division, there's no majority number there, is there? Okay. All pretty much the same number. And in fact, you can't even work out a standard deviation. When you have a power law where the exponent is -1, you can't work out an average or a standard deviation. So the whole idea of classifying firms into perfectly competitive just doesn't make any sense looking at the data itself. Now you can see the concentration. You can also see the absence of a representative size. But economics continues talking about representative firms and representative agents. Given the data, there's no such thing. Okay. So it's a non-existent taxonomy. What it does instead, it says that firms are all profit maximisers. So we assume they're profit maximising, and this is what determines their size. We assume they all suffer what's called diminishing marginal productivity, and that's what I'm going to be hammering mainly in today's lecture. We classify them to four large types where none of them actually exist. Okay? This is a taxonomy of animals where none of the animals actually exist. Veblen was the first person to point that out. And they all sell on spot markets. There's no stocks included in the models, no option markets, or that they do have models of option markets, but the predominant market is, as everything's a spot market. And all the buyers are after is getting the lowest possible price, and there's no continuing relationship between buyer and seller. Now, that is supposedly to let us focus upon the core essence of how firms behave. So you're ignoring all this stuff is supposed to be unnecessary, okay? What I'm talking about with you is unnecessary detail, and they're leaving it out. So you have a single industry with a single product, privately owned, no internal structure considered, and no specialisation. The firm is marketing its own stuff, etc., etc. Now, you do have generalisations, but it all starts from this foundation of non-generalised, the idea of a single firm maximising its profits under conditions of diminishing marginal productivity. And, well, shouldn't we ask firms what they do? Now, I've got to thank the Rethinking Economics movement here because they produced this cartoon just a couple of days ago. You read the cartoon? So the guy suggesting interview gets thrown out the window. Now, I wish that was a joke. I wish it was funny, because it isn't, because it's actually very much characterised as what happens in the real life. There's a book by a guy called Mas Colell called Microeconomic Theory. Have you got that? Did you buy that?
I've got that book.
Okay. What do you use it? Do you prop your computer up or keep your bedroom door open at night?
It's in a box.
Pardon?
It's in a box waiting to be sold.
Yeah, it's a monster, about 1,000 pages thick. Okay. And it has on Amazon USA, it has 93 reviews. So it's been read quite a bit. So here's Microeconomic Theory, and it weighs 2.8 pounds. It goes you over a kilo. Okay. So you get a lot of paper for your money, which is quite useful. And its bestseller rank in Amazon last week is 69,000. So that's not bad. It's still selling quite a few copies. Most of it sold through university textbook shops rather than Amazon. So sales are higher than you'd see here. 93 reviews. Here's one called Asking About Prices. Okay. One review. Its ranking is 2.6 million. Okay. 93 reviews. One review. Do you want to have a guess who wrote the review? Me. Okay. They bloody well ignored it. Now, I can understand them ignoring. I think my books have got 40 or 50 reviews on Amazon. So they've read, my book's been read more than this one's been read. But it actually, do you know who Alan Blinder is? Have you heard the name before? He was a deputy director of the American Economic Review Association and also the Federal Reserve. So he's, you know, you've got a highly significant person here being completely ignored. So you have all these various things about production. Hang on, actually that slide's in the wrong spot. I'll just jump through that one. I'll have to go back to that one later. I think I shuffled that slide around for another lecture. Hang on. That's my mistake. I better just jump forward a bit. I put that in at the wrong point. What did I do to poor old... Don't tell me, I don't think I deleted it. Oh, here we go. I moved that around. I'll go back and fix it up in the slides I put up on the screen. I wanted to get to Alan Blinder here. So let's just go and take a look at Alan. So the theory tells you, and I'll explain this in a moment, you have rising marginal costs because of diminishing productivity per variable unit. But the empirical data that Alan Blinder found is that the marginal cost is constant or falling. In other words, the opposite of what's assumed. They assume an upward sloping marginal cost curve. Alan Blinder in general found a falling marginal cost curve. Now, Alan Blinder was Vice President of the American Economic Association and a Vice Chairman of the Federal Reserve. You don't get much more official and inside the club than Alan Blinder. And in reviewing what his data was, said the overwhelmingly bad news for economic theory is that only 11% of GDP is produced under conditions of rising marginal cost. Firms report having very high fixed costs, which again is different to what I showed you in the diagram beforehand, roughly 40%. And many more firms say they have falling rather than rising marginal cost. So this is not simplifying the data. The assumption that's made was not an assumption that threw away the non-standard and kept the standard. It threw away the standard and kept the non-standard. Okay? And that's the sort of thing they defend by saying we're just like the London Tube map, which they're not at all. So what he says is you get a very different picture of the costs of individual firms than you find in the textbooks. And that's quite true. So what do? They ignore it. It's not a simplifying assumption at all, it's a complicating assumption. So he looked at 7%. When he worked out that this is a huge survey, it's the biggest ever done. He hired PhD students to do the survey. They went out to actually do interviews, face-to-face interviews, with executives in companies from the top northeast quadrant of the United States. And Blinder worked out after he'd done all the surveys and they got the responses back, that the firms he interviewed were responsible for 7% of US GDP. If you think about political surveys you see, which would then predict what's going to happen in polls, those political surveys often have only 2,000 people in a country of 60 million. So to be getting 7% of GDP, you're talking a seriously big sample. And I would never accuse Alan Blinder of being a good draftsman, but that's the diagram he has in his book to show what he was told. So 33% of firms said their marginal costs fall. 8% said they fall with occasional jumps. So that's 40% plus saying falling marginal cost. 40% say constant, and 8% say constant with various peaks. Only 11% say that. Now, that's what the textbook says everybody. Okay. Now, summarising his findings, this is the complete table of data from the book itself. It's probably too hard to read. Not too bad from this distance. Let's just take a look at some of the major ones. First of all, price adjustments are infrequent. The average number of adjustments per year is 1.4. Most firms didn't adjust their prices at all on an annual basis. Okay. Fixed costs or fixed contracts which fix the prices were quite common. More than 1 in 4 contracts had a fixed price, and often these contracts would last 3 to 5 years. Many of them said, well, implicitly, we just agree not to change prices all that rapidly. That's another 2/3 of prices. Most sales are to other businesses. Rather than sending to end consumers, which is the Bob's Bagel Factory vision, most firms sell to other firms. The reason that's going on is to make something like this, you've got to be buying water off one person and plastic off another. Okay, so most of your products you sell are intermediate products. So 70% of what's produced is needed is inputs to produce other things. Okay, only 30% turns up roughly as actual final output. And there's regular customers. 85% of your customers are repeat customers. And fixed costs are very high. 44%, pretty much half the costs, and marginal costs are falling. So it's not a simplifying assumption to have rising marginal costs. Why do they do it? Well, let's first of all say, is it an aberration? Could this just be a freak, really, really bad survey? Unfortunately not. There's been, of the order, there's certainly more than 10, I think it'd be about 30 or 40 surveys that have been done over time. Every last one has found the same tendency in the data, and most of them report that no more than 1 in 20 firms have rising marginal cost. In fact, it's worse than that, I'll show you in a moment. So my favourite survey was done in 1952, the year before I was born. That's how long they've been ignoring this data for. And what they did was show managers 8 hypothetical cost curves looking like this. And that's the average cost curve I showed you before, to an average cost per unit of output. And only one of them is strictly neoclassical. That's what most of you take a look in the drawings and textbooks, you'll see what they've got. Curve bottoms out towards the left-hand side of the graph, and then rises a lot towards the right-hand side. That's a standard graph. Now, when they got their responses, one firm out of 334 chose that cost curve. Now, for being generous, I can call 4 and 5 neoclassical. 5's a stretch. 4, maybe. Maybe the diagram is drawing close to reality. So it's 3 more firms for the number 4 and 14 for 5. 200 of them closed 7. Costs are high to begin with and fall, and then flatline. So that's rising marginal cost. That's where the 5% comes from. Constant or falling marginal cost. And the best survey this is done by a recently deceased non-orthodox economist called Fred Lee. A brilliant book called Post Keynesian Pricing Theory. It does a comprehensive historical survey of all the work that's been done to look at what firms actually do, and tries to build a mathematical model as well of the actual cost structure of firms. So the obvious simplifying assumption there, that if you were told that 85 to 95%, even 99% of firms, if you look at that, if you're not generous in your definition of a neoclassical curve and just use number 3 there, if that's the situation, and only a tiny fraction have rising marginal costs, then the simplifying assumption is to assume marginal cost constant. Maybe you can go as far as saying it's falling. Okay. And then if fixed costs are 44%, then your fixed costs at the level of standard output for the firm, most of your costs should be evenly divided between fixed and variable costs. So this is a simplifying assumption. This is my London Tube map of the actual costs of firms. Constant marginal cost. Average fixed cost, necessarily a rectangular hyperbola. Add the two together, you get average total cost, and the standard level of output is going to be about there. Okay? That's a reasonable model, simplifying assumption for the cost structure of most firms. Now, why don't neoclassicals do that? Here's Mankiw again. Why do they do this? Take a look. Here we have Thirsty Thelma. They're good on alliteration, I'll give them that. Okay? Thirsty Thelma's average cost curve. Okay? Another imaginary example. If there was real data, they'd be using it. Real data fitted the theory. Okay? They don't. And the thing is, they're so attuned to thinking this way, they don't even realise that they're using fictional data. That's what I find quite hilarious. My favourite book in there is probably Varian's book, and Varian's book has all these graphs and absolutely no numbers on any of the graphs, just drawings. So 1 in 10 have rising marginal cost at best, more likely 1 in 5, frankly more likely 1 in 100 have rising marginal cost. Fixed costs are way down here, huge gap between the two. No, they're pretty much the same. So they're Ptolemy epicycle type theories. They're not simplifying assumptions of the real world. They're assumptions necessary to make a false paradigm look like it works. Now, why are they so insistent on this particular false paradigm? What's so important about rising marginal cost? Well, again, I'll just take a look at what I want to draw. That's what I do in terms of modelling the cost of the firm. And then what I'd say is, well, you know, you have a target price level versus this thing over here. Well, the reason is because with this diagram, what they call the supply curve in your textbooks is the section of the marginal cost curve above average total cost. Actually above average variable cost. I think I may have got that particular piece of the fantasy wrong. That further down, that doesn't quite work. But they're saying above this point you might as well produce, because you're making more than it's costing you to produce the output. Okay? Now in the real world there's no such segment. If you have constant marginal cost, then marginal cost is always going to be below total cost. If you think about, for example, building an automobile, and you've got your variable cost of the metals you've got to buy, the plastics, the labour, etc., the electricity to run the factory, what this is saying, if you're paying €20,000 to buy the car, you're probably paying 10,000 of that, roughly speaking, is the variable cost, and 10,000 is the fixed cost of the factory. So to make a profit, you've got to price it above €20,000, well above €10,000. Okay. Otherwise, you'll make a loss. But they think you're going to price them up here and make a profit. So the realistic argument is, if you actually set price equal to marginal cost, which all their models assume is the ideal situation, price should be equal to marginal cost. Okay? If firms did that, they'd go bankrupt. So it's not a survival strategy for a firm to set price equal to marginal cost, it's a bankruptcy strategy. So what firms are actually doing is something like this, setting price as a markup on those variable costs and selling past this point, which they call, anybody know what that's called, and accountants call it all the time?
Break even?
Break even point, yeah. Past the break even point you make profit. So the stuff accountants get taught about break even and stuff like that's sensible. That's more realistic of how firms actually behave. So why does marginal cost not rise? Well, the basis of rising marginal cost is the idea that there's diminishing marginal productivity. Okay? You have rising costs, not because you're paying more per input as you increase the output. You're assuming you pay the same rate for workers no matter what. They pay the same price for electricity no matter what scale. They assume the price doesn't change. What they assume is the productivity of each individual worker might rise for a while, but ultimately declines. Because what you're doing, you've got a fixed stock of capital in a factory. So you've got 100 machines. So imagine you've got a machine-based rather than production line manufacturing system, and you have variable labour. You can have a variable number of workers you hire for the machines, you pay a constant wage for, and there's some ideal ratio of workers to machines, say 10 to 1. 10 workers, 1 machine. In fact, I can give you an example. I bumped into a guy flying out of somewhere in Europe who was heading off to China, and his firm makes what's called RFID chips. Okay. And each machine produces 9 million per year, and it has 9 workers. That's if it's being used in Austria. The same machine used in China produces 5 million and has 14 workers. He has no idea what the extra 5 workers do. It's a part of the culture that they require that many extra, and he's trying to get the production repatriated back to Europe again. But the ideal ratio for that is 9 workers per 1 machine. Okay. Now what they say is, well, when you first start out, you'll have these 100 machines in the factory and only 1 worker. So you get your 1 worker to run around the 100 machines, operating all of them at once. Pretty innovative. It takes a long time to jog past 100 machines and press the buttons to get back to the first one again. But once you get to the ideal ratio of 10 workers per machine, then you get maximum productivity. And if you want more productivity, you add more workers per machines. That's total nonsense. Because what you're assuming is, if you have 100 machines, you'll operate the whole 100, even with only 1 worker. No, you won't. You won't even turn the first machine on until you've got 10 workers. You won't turn the second on until you've got 20 workers, etc., etc. You will leave the machines idle. And that makes eminent sense. So if there's only enough demand for 100 workers to be employed, then you'd use 10 machines, leave the other 90 idle. In fact, you'd have much higher numbers than that. If you build a factory with a functional company already behind it, you'd probably produce a factory which was 50% to 70% occupied when it's first turned on, and then you have room to grow over time, and then you build the next factory and the next factory as you expand production. So you start with a level of overcapacity, and you simply don't use the additional machines until demand makes it necessary. So output per worker is constant until you hit capacity, and that's why you get that constant marginal cost curve. And this is now to go take you some of the data that Blinder found that should be used to work out a simplifying assumption model. So he said, for a start, about 70% of sales are other businesses, and that's because production is an input-output process. You have to buy inputs from somebody else to produce your own outputs. Your outputs will frequently be inputs to somebody else's production system. And the net output that's actually sold to end consumers is a small proportion of the total output. So firms themselves are selling to other businesses most of the time. And in that situation, your other business is going to want reliable pricing. It's not going to have to adjust its prices every day because you're charging a different price every day. It'll want stable prices. That's the first element there. Secondly, it's common to have contracts, again for the same reason. You have a firm trying to guarantee that its inputs can be reliably priced for its outputs over time. It will enforce contracts on you. 60% is covered by implicit contracts. Fixed costs are extremely high. And then it says a great deal of microeconomic theory is called into question. Now this is, as I said, this is a deputy president of the American Economic Association, not any raving lefty, okay? And they ignore it. That's not simplifying assumptions at all. Speed of adjustment. Economic theory again has rapid adjustments in prices. The idea is that price adjusts to bring demand and supply into equilibrium. You don't, in other words, have stocks that are unsold. And I have been in many, many meetings with mainstream economists. One of my favourite was I was actually approached by the New Zealand Treasury to build models using my software of the New Zealand economy. And I was blocked by the economists there, quite literally, including one little Scottish bloke who was just a renewed recent employee and was rapidly trying to stop me being brought in and funded by the New Zealand Treasury. But one of the others at one point said, look, I look down the markets and I see equilibrium. And I said, so you look down the street and you see car yards that are empty every night. And he said, what? And I said, well, if it's equilibrium and the price was adjusted to clear all stocks, there'd be no cars left overnight. There'd be no unsold stocks. What actually happens is stocks adjust. If you don't sell all your Audis today, the ones that don't get sold remain in the car yard tomorrow. If you run your stocks down, you tell the factory to increase the production rate. It's stocks that adjust. Quantity adjusts, not price. So all this stuff in the theory is completely wrong. 23% of firms do adjust. They said if there's a shock to their cost, they put prices up straight away. 20% say they take a month to adjust. Another quarter, 1 to 3 months. Yet another roughly quarter, 4 to 6 months. Of a fraction taking almost a year to do it. So here's the frequency of price adjustments. And on average, the median number of adjustments for firms 1.4 times per year of the firms they spoke to. So less than 2% made adjustments every day. Okay, 1.6%, so they'd make more than 365 changes per day. Only a tiny fraction actually did what the model assumes all firms do. 50% only change prices only once a year, up in this level. So very, very sluggish versus the neoclassical theory, very, very rapid price changes. And so most sales are occurring out of equilibrium, rather than being that point where the flow of supply is equal to the flow of demand. They will differ, and the difference is made by a change in your outstanding stocks. That's a realistic model. You have a stock adjustment model of what firms do, not a price adjustment model. And here's the reasons why they say they don't change prices more often. They don't want to antagonise customers. Now, if you're selling to spot market people, you couldn't care about antagonising, you'll never see them again. That's the bazaar. You go shopping in a bazaar and you're a tourist hopping off a ship and going to a bazaar somewhere in Turkey. That's the sort of pricing you'll see there. But generally speaking, you're talking actual firms. They've got repeat customers, they don't want to annoy them. Then you have pressures from other firms. You don't want to put up your prices because you don't think the others are going to put up their prices. That stops you making the move. Cost of changing prices is substantial. Your costs don't change that often. That's important as well. All these things mean what they call a simplifying assumption is actually a fantasy. Who do you sell to? Well, economic theory has utility maximising consumers meeting profit maximising firms. And no buyer-seller relationship, you just want the lowest price. Okay. 85% are to repeat customers, and most of those are other businesses. So again, it's not a simplifying assumption, it's a complicating assumption. 70% to other customers, 9% to government, only 1 in 5 sales to final consumers. So even again on that front, you'd be simplifying the theory would almost leave out the final consumers. Of course, you can't do that, but they are they are a tiny product component of total sales, and that's why you get those infrequent price changes. You don't want to disturb existing relationships, and you don't need to make the changes anyway because your costs don't change as much as the theory says they will. Because if you have constant marginal cost, in fact diminishing marginal cost is the rule, and your average, as you increase volume, your average fixed costs necessarily fall. If there's an increase in demand, you actually increase your margins. You don't need to increase your price, you're getting more per dollar because your costs probably have fallen. So you're not about to disturb that by putting prices up, which might drive people away from you to another supplier. So here's the sales made to regular customers. Only a tiny percentage don't sell, don't have repeat sales. The vast majority have repeat sales. And if you had regular ups and downs, then you'd be antagonising the planning processes of other businesses, and you disturb your other firms. It just doesn't work anything like what the theory says the firms actually do. Again, they talk about everybody doing things what they call real prices. Now, real means accounting for inflation. So again, conventional theory says, well, prices are set to get a real rate of return. You ask the firms, nope, they don't even look at the rate of inflation. Most of them. This work was done in the 1990s. Inflation was a lot lower than the 1970s and 80s. Maybe back then they did, but again, less than a third take a look at the inflation rate in setting their prices. And elasticity of demand is an important concept in economic theory. If you go through a standard course, you'll spend a lot of time working out how much does demand change for a change in price. Okay? And the theory is that firms face very elastic demand curves because a small change in the price causes a large change in the quantity that you get. Okay? And in that case, what you should find is that there should be high elasticity of demand. Most firms should be experiencing a high elasticity. Now, he said most firms don't even calculate elasticity. And 40% said their elasticity is 0. In other words, if they cut price by 10%, there'd be no increase in sales. 70% said their elasticity is below 1. In other words, if you drop your price, you're going to reduce your revenue, total revenue, not increase it, for 70% of firms. Only 2.5% said they had elasticity greater than 5, which is the sort of level economists would assume. You know what assume stands for, by the way? Okay, it's to make an ass out of you and me. An old joke. So 1/6 of production fits what they think is the norm. And what that means, the thing, if you only get an increase in revenue for a cut in price, if you face elastic demand. They're saying 70% of them don't. So why would you want to cut prices? You're not going to compete on price, in other words. And the basic idea is here, if you imagine I'm just drawing a diagram here. If you imagine you've got a demand curve that looks like that, then if you make a small change to your price, you're going to get an increase in your revenue. Okay, if you go down from here to here, the area of the rectangle is going to get bigger. But if you face a demand curve looks like that, if you increase your price, the area of the rectangle is going to fall. Okay? Imagine bringing it down to here, you're going to have a tiny rectangle. So big rectangle up here, drop the price, small one down here. For this one, small rectangle here, drop the price, big rectangle here. The rectangle tells you total revenue, price times quantity. Follow that? It's not important, but this is why the theory itself is wrong. A fixed cost important? Well, again, theory says it's not, because they say fixed costs are sunk. Once you've built the factory, you shouldn't be taking the factory's existence into account because you already paid the money. Doesn't matter. And variable costs determine the scale of output, and you should operate as long as your revenue exceeds your variable cost. That's the point. I couldn't do that on the previous diagram from Mankey because of the way the curve was drawn. But that's the usual story. Now, what Leiter found is fixed costs are incredibly important. First of all, firms didn't really make the distinction. They just went on operating. They had to build the factory, so it was a case of build the factory and have the capacity for output you need, but they didn't divide the costs up in a conscious way. And again, 44% of costs were fixed and 56% variable on average, or median, I think. So fixed costs are more important in the real world than in the theory. And here's the percentage. The median was 40%, the mean was 44%, with a wide standard deviation. So for quite a few firms, fixed costs were a lot higher than variable costs, and for most firms, they were close. So they're not irrelevant in the real world. They're much higher than the theory presumes they are. And that's an example I gave. This is probably, I'm not sure the cost has gone beyond $1 billion now. But building a semiconductor plant, you've got to look at a cost of a couple of $1 billion to build the thing. You're not going to ignore that cost. And it's a much larger proportion of total costs. And then fixed costs will be more important in the real world than economic theory. And not just a trivial thing you can ignore, seriously, significantly more expensive. And will shifting supply and demand cause fluctuating prices? The reason that Blinder looked at this is he's part of what's called the new Keynesian wing of mainstream economics. And part of what they have is an explanation for why there's disequilibrium is sticky prices. So he's trying to say why are prices sticky? Because in the theory, prices move very freely all the time. So he said, well, if you have a rising supply curve, then you're going to have regular fluctuations. If demand increases, you're going to have to put the price up. Demand falls, you'll cut the price. Blinder's results no, they're not shifting up and down along upward sloping supply curves. In fact, if they're downward sloping, except counter-cyclical movements. If demand rose during a boom, you'd expect price to fall, not rise. And you'll find, in fact, in the empirical data, one of the papers I've got there, that's what was found by some of these conservative economists. So you don't get the cyclicality, you don't get the variability in price that they think is a norm all the way through. And do stocks matter? Again, conventional theory leaves out stocks. Now, again, you go to a supermarket, you're seeing a stock of unsold goods. Okay. And the firm is adjusting how many it has on the shelves, adjusting what its orders are on the basis of how many of the stock has moved yesterday. Okay. I happen to live on a retail street. I get in the morning and I just walk past truck after truck, restocking. And the restocking calculations are based on how much sold yesterday, effectively, depending on how fast they can make the goods. So 54% of output is produced as stock. You're not selling for final consumers, you're producing to change the level of stock you have to be more in line with what you think is necessary for the number of customers, the shelf life of what you're buying, etc., etc. And wholesale and retail, they sell primarily from stock, and fluctuations in stock play the buffer role. Rather than price adjusting, quantity adjusts. So this is, again, going from the bottom up because this is where the data actually comes from. Most firms are selling to stock, producing to restock their current levels of outstanding products in either a warehouse or a retail outlet and so on. And is economic theory relevant? Well, of course it is, if you ask an economist. Ask Blinder, no damn way. Okay. Firms have got falling rather than rising marginal cost. What you get is a picture of the real world that's very, very different. The simplifying map, so-called, is not simplifying at all. So there's something weird with their methodology there. And why do they make that assumption? It's not because it's simplifying the real data. It's contradicting the real data. Okay? It's because it's necessary to maintain the paradigm. And it's not just empirically false, it's logically false as well. When you think about how firms operate, so the first person to make a strong case of this was Piero Sraffa. Has anybody heard the name Sraffa before? You'll hear him a fair bit from me, SRAFFA, an Italian academic who worked in Cambridge for a fair bit of his life. And what you'll do is, if you have fixed resources, you have to buy inputs no matter what. So you're buying production lines, you're building a factory and so on. You will use that fixed resource at its maximum efficiency at all times. And parts you can't use at maximum efficiency, you will leave turned off until you need to use them. So you leave the machines idle until you can use them at their optimal rate. And this is Sraffa writing back in 1926 saying, he spoke about having if you define industry very broadly, like for example agriculture, then you have agricultural use of land and housing use of land and industrial use of land. And if you try to produce more agriculture, you've got to demolish some factories, okay? So that there's a rising marginal cost in that case. But if you do it, you're going to make land more expensive. So you get a feedback between demand and supply. If you say, for example, making pins, and you have a particular punching machine you need to make pins, then he said if you need to produce more pins, you'll buy more punches. Okay? The fixed resource will change. Or if you have a production line, you might have a factory with 5 production lines. You'll use 4 of them. 3 if demand drops a lot, you use all 5 if demand rises a lot, and you'll start planning the next factory. But you'll be using the factory with the optimum ratio of variable inputs with labour and energy and raw materials to the machines themselves. So you get a constant rate of return coming out of that. And therefore a constant return per unit, variable unit, means constant marginal cost. And of course if the factory is well designed, the closer it gets to capacity, the more efficient its production is. And therefore your costs will fall over time. So what he's saying here, if you take leaving out the so-called long term, the imposing structure, and this comes from Marshall, the imposing structure of diminishing returns doesn't apply. It's a figment of an armchair theorist. Okay? It's not the real world, it's somebody sitting down in an armchair imagining what they think the real world is like and building an economic theory in it, but it actually contradicts what applies in the real world. So they're not simplifying assumptions at all. And I love this statement by Sraffa here. Businessmen who regard themselves as being subject to competitive conditions would consider absurd the assertion that the limit of production is found in the internal conditions of production, which doesn't let them produce more except at a higher cost. So that's nonsense. So the chief obstacle they've got is marketing. Okay? It's harder to sell. Okay? It's an aggregate demand constraint. And that's one reason firms have excess, and I don't talk about this in this particular lecture again because of time, but one reason firms have excess capacity is to take advantage of mistakes happening at other firms. If you, for example, are a tyre manufacturer and one of your rivals produces a tyre that blows out and causes a number of accidents, then you're there to increase your sales easily to take advantage of their mishap. And the vast majority, even when the economy is in massively, American economy massively close to full employment back in the 60s and 70s, when you look at the level of capacity utilisation, it was at least 10 to 20% of capacity which wasn't being used. Because it's there for competitive reasons. You need to have the excess capacity to take advantage of things going wrong with your competitors, to be able to expand production rapidly when seasonal pressures strike and so on. So the point is that factories are designed by engineers. Engineers know what they're doing, and they design them in such a way that the closer to their capacity, the lower the costs get to be. And this was put forward by an economist back in the 1940s, I think, this particular paper. Yeah, a fact that makes it physically impossible for a firm to determine how much to produce by equating marginal cost and marginal revenue, which is the conventional theory, because for most of with constant marginal costs, that's not going to be profit maximising for you at all. The limits aren't going to come from marginal cost equals marginal revenue. limits are going to come from when you can't get enough sales. Okay? And think about the theory itself says there's some optimal amount. Beyond a certain point of production, the firm will lose money. Now that would mean, if that were true, one of the main roles of a marketing manager, we would ring up and tell the marketing staff when to stop selling because marginal cost exceeds marginal revenue. Do you think any sales managers ever told staff to stop selling? Okay. But that's the theory they're using, so it's nonsense. And notice the journal and the date here, because I want to talk about methodology and why you make absurd assumptions like this. 1947, American Economic Review. Okay. Why do the neoclassicals ignore empirical evidence like this? It comes down to not just Friedman's paper, but Friedman's paper enunciated it very, very clearly. In 1953, he wrote a paper called The Methodology of Positive Economics. And when you criticise a neoclassical about simplifying assumptions, they say assumptions don't matter. Okay? They're quoting this paper. They haven't read it, most of them, but they're still quoting what they know the paper says. And here is Friedman saying, well, there's been all this discussion of monopoly and monopolistic and imperfect competition, neglecting the idea that you should use simplifying assumptions like rising marginal cost. And he said it's motivated by the argument that we don't really find this model doesn't exist in the real world, it's a false model. And then said this is mainly derived from saying that the assumptions are inaccurate. So this is back to the accuracy of assumptions thing. And he said the lengthy discussion of marginal analysis is a clearer though much less important example of this. In other words, ignore this stuff. Don't read it. So he defends the idea that unrealistic assumptions are necessary, and that's what has become part of the mindset of mainstream economists. So they're saying, you're asking irrelevant questions. Do businessmen actually consult these curves? Well, they don't. But that doesn't matter, because if they don't do something like it, they wouldn't be good businessmen. That's the logic they use. It's a long set of quotes here from that particular paper, but he says, consider what a billiard player does. You look at somebody sinking. Does anybody here play billiards?
Occasionally.
You okay at it? Badly, so do I. Yeah, whenever I play it at a pub. But you see somebody doing it, it looks absolutely brilliant. What he's saying, well, it looks like maybe they're calculating all the equations that are necessary to sink the balls as if they do it. And we know that they don't do it. We presume they don't do it, but unless they did something like it, they wouldn't be sinking the balls. So he's saying we can do it as if they're calculating those equations. That's the sort of thing. It's only a short step from these examples to saying firms behave as if they're maximising expected returns, as if they're equating marginal cost and marginal revenue. But this as if only works if marginal cost rises. It doesn't. Okay? So his defence of unrealistic assumptions doesn't make sense. Here he's saying calculated marginal cost and marginal revenue and push them to the point where they're equal. Okay? But the empirical data says if they did that, they'd be losing money. And the conditions that they actually equate in the first place don't apply. Once you get past that break-even point, you're getting increasing revenue all the time. You're not seeing diminishing marginal revenue. Okay. Now, so they don't actually solve this, but we know that unless they did it, they wouldn't be successful. And you wouldn't ask a billiard player because he might say he rubs a rabbit's foot and that's why he sinks the ball. Saying basically ignore the empirical data. But they're assuming the empirical data has the component that they think is vital, diminishing marginal productivity, therefore rising marginal cost. It doesn't. So it's as if doesn't work. But with that fog of as if assumptions, they ignore the empirical data and still saying they make simplifying assumptions when they're not. They're making complicating assumptions. So again, this whole idea, I'll put the quotes there for you to read later. I'd recommend looking for the article as well. It's not one you can find in a journal, so that's why I put a lot of the quotes here. But he's saying natural selection justifies it as well. If their profit maximises, then they must be doing what we say they do. Therefore, what we say they do is what they do, whether they know it or not, that type of thinking. Now, again, it only applies if marginal cost rises. We empirically know that it doesn't. So the as if argument Friedman is using here doesn't justify it. But what he's doing is championing unrealistic assumptions as simplifying. We find falling marginal cost, therefore we assume rising marginal cost. That's not a simplifying assumption. That is an unrealistic assumption. And this is what's called the F-twist. This is a particular statement here. Truly important and significant hypotheses will have assumptions that are wildly inaccurate. And therefore, the more significant the theory, the more unrealistic the assumptions. Now, what that's being done is to justify simplifying assumptions that ignore the minority of cases that don't fit to concentrate on the majority that do, which is where the London tube map defence comes in. But it's not what they're doing. It's what they justify their behaviour on, it's not what they're actually doing. And he says the hypothesis is important, it explains much by little, which is true. Okay? In the case of Newtonian theory about the motion of the planets, you assume all planets are point masses, all subject to the inverse square law. You get a pretty good approximation of the actual behaviour of the planet. But that's not what they're doing here. So he's saying descriptively false assumptions are a good thing. It's true if those descriptively false are leaving out the tiny number of exceptions, or the small number of exceptions to a general rule. But what they've chosen is take the tiny exceptions and call the tiny exceptions the general rule. And so the assumptions are never realistic, they've just got to be sufficiently good approximations, and all you've got to see is whether the theory works. That's the assumption, that's the defence they'll use. Now, what I've found from my own experience in working in economics, that is total, to use a technical term, total bullshit. Okay? If you submit a paper which doesn't make the assumptions they expect, they reject it because you don't make the assumptions. I've had that happen, and I've got written proof of that. And all schools of thought do judge other schools of thought on the basis of the assumptions. So you have a neoclassical, and they'll defend their assumptions and say it's simplifying assumptions, don't worry about it. They talk with a Marxian, they're saying you're assuming labour produces all output, that's got to be wrong. Okay? So their own behaviour contradicts the defence they're using in this particular case. And in fact, when you look at how macroeconomic theory developed over time, it was driven by the desire not to make it more accurate relative to the data, but to make the assumptions of macroeconomics consistent with the assumptions of micro. Okay? There's a huge driving force to make the assumptions consistent. And they do criticise the assumptions of other theories all the time. So, you know, they believe it, but it's a cover at the same time. And that's the same thing if you talk to anybody who believes in a religion. Okay? You can tell that I'm agnostic. But this is the religion thing. It's behaving like religious groups, not behaving like scientists. So this is my favourite with Ben Bernanke. You know Ben Bernanke, of course. Okay, talking about Hyman Minsky. You've heard of Hyman Minsky? I asked that question a decade ago. I would have got nobody answering yes. Now everybody knows Hyman Minsky. So Minsky and Kindleberger argue for the inherent instability of the financial system. And he says, but in order to do so, had to depart from the assumption of rational economic behaviour. That's criticising for their assumptions. They then finished up with a little footnote. I don't deny the importance of irrationality, but it seems the best research strategy is to push the rationality postulate as far as it will go. So I reject reading Minsky and Kindleberger on the basis of the assumptions they make. That's standard behaviour for neoclassicals. And that's the only reference in the entire book. The book is called Essays on the Great Depression. And Minsky was clearly one of the people with a sound explanation of the Great Depression. That's the only reference he makes to Minsky in the entire book. So what you get is a challenge to the logical consistency of these assumptions. And scientists do try to build theories that they see as descriptions of reality. Okay? This is what the real data is. Our theory has to explain the real data. Whereas neoclassical economists, this is what the theory is. Who cares what the real data is? And the best, and so I do recommend reading this paper by Musgrave. It's a paper you can find online. He says the whole idea about the more significant a theory, the more unrealistic assumption, applies if the assumptions are literally simplifying, leaving out the occasional exceptions to a general rule. That makes sense. But he classifies those as what he calls negligibility assumptions. So they're assumptions that say the particular matter you're ignoring is not important for the general case. Domain assumptions and heuristic assumptions. I'll talk about a bit about each of them, give us a bit of time towards the end. And if the assumptions don't matter, defense only matters if what you're assuming away is negligible. So, for example, again, putting myself here, you're saying something is unimportant for the particular situation you're looking at. So let's go back to the experiment by Galileo dropping 2 lead balls out the Leaning Tower of Pisa, okay, to prove that the heavier ball fell at the same speed as the lighter ball. Now what he's assuming in that particular situation is that he can ignore wind resistance. When dropping 2 lead balls, yes, you can over quite that distance. If you drop them from the height of a large aeroplane, maybe there might be something different with terminal velocities coming in and so on. But you can ignore wind resistance and still get a good calculation coming out of it. Domain assumptions say that the theory is relevant if some assumed conditions apply, but it's not relevant if those assumed conditions don't apply. And my favourite example of that is Newton's theory of gravitational attraction. Because to work out the idea that the planets follow an elliptical orbit, he assumed there's one sun and one planet. And when you do that, the planet will follow an elliptical orbit. Does anybody know why that's the case? Imagine this great mass of rotating matter out of which accretes a sun and a planet around it in a solar system. The direction of rotation will be, unless it's perfectly, the planet will be attracted by the sun, but its orbit will not be perfectly centered on the sun. If it's away from the sun, then it will follow an ellipse. Okay? The shape will be elliptical, and Kepler was the first one to identify that. So there's a single planet, that planet will follow an elliptical orbit. Now, that was for one sun and one planet, 2 objects, M1 and M2, attracting each other through the inverse square law. Very, very simple when you look at it. It's very complicated to think it up in the first place, but a simple formula. Now, of course, we knew when this was worked out there's more than one planet. So the question was, is there a similar formula for more than one planet? And the King of France, I think back in about 1800 or thereabouts, nobody had solved this problem. So he set an award of 100,000 francs to the first person who could solve what's called the many-body problem. And it was finally solved by Poincaré, who's one of the world's great mathematicians, in 1899. And what he showed was there's no formula, and in fact the motion of those planets is chaotic. Okay? Follow very, very complicated patterns, not the smooth patterns we see in the stars and the moons above us. There's no formula, and the paths follow chaotic. In fact, there's a lovely video, I'll see if I can send you a link of it, that has changed the location of Jupiter a couple of 100 million years in the future. Okay? Moving your pen on the desk is enough to change the location of planets over a huge time period, hundreds of millions of years. So in fact the planets, which was one of the ideas about Laplace's idea about giving a set of formulas and I can predict for the infinite future, no you can't. Okay? Complex systems chaos theory comes out of that particular insight. So what that means is if you see a multi-planetary system, there have been collisions in the past, and we know that the Earth was the product of at least one massive collision between itself and another proto-planet. Otherwise we wouldn't have the size of the core we have in the planet. The Moon has no core, so the collision gave us a more massive magnetic core, which is part of why life can exist, because we don't get irradiated, we don't lose our atmosphere, because the magnetic field around the Earth protects us from the solar wind. So all these things are important elements of a realistic theory. So the domain assumption here is that if you have a solar system with just one planet and one sun, then there'll be an elliptical orbit. If you're in more than that, chaotic orbits, and then what you actually see will be the product of a chaotic evolution process over hundreds of millions of years until such time as the orbits settle down the way we've seen our own planetary system. But it's not because they've been following ellipses all the time. They're interacting with each other, and those ellipses change the other ellipses. So you get an evolutionary explanation, which is a better assumption. Now the final class of assumption Musgrave talked about was what he called heuristic assumptions. And that's where you make an assumption, you know it's false, but you're using it as a stepping stone to a better theory. And for example, in explaining the theory of relativity, there's a wonderful book by Einstein called, I think it's called General Relativity, a simple explanation that any intelligent person can understand. And it's beautifully written. Do not try to read his advanced lectures. Okay. You've got to know mathematics to an incredible scale to know them, but he did a beautiful little theory here, and this is how he actually worked it out for himself in the first instance. He imagined somebody walking along a train and walking across a train, and saying if you geometrically sum the motion of the person's walking across a train carriage while the train carriage is going forward, then you can produce a trigonometric sum of the forward motion of the train and the sideways motion of the passenger. It looks like this. So you've got your train going that way forward, and imagine it's moving at 0.9 times the speed of light. And then somebody's walking across the carriage, and imagine they're walking at 0.9 times the speed of light. With the train and the passenger, you will say the trigonometric sum is going to be the sum of the two numbers. But we know nothing moves faster than the speed of light. So the sum must be less than that. So he said we're making this assumption that can't be maintained. The left-hand one, I've assumed that to begin with, it can't be maintained. We'll assume its correctness and see it has to be modified to get the actual answer. And that's the logical process he went through to get the special theory of relativity. Okay? That's a heuristic assumption. So you can make false assumptions so long as they're a step to a more correct theory. But that's not the case of what neoclassicals did at all. So this is the right way. The sun-planet stuff that Poincaré did is the right way to build a theory. You assume, first of all, the influence of other planets is negligible, then the Earth will follow an elliptical orbit around the sun. If you assume they're not negligible, then you get the elliptical thing only applies in a solar system without other large planets, just the one planet. You drop the assumption of non-impact, and you get a general theory about the evolution of the solar system, which we now know is correct. The collision-based theory of how the solar system came about. When you have a three-body problem, you get the idea of chaos theory, which is a much richer understanding of reality than Newton's original idea of elliptical orbits. So a more realistic set of assumptions give you a more accurate theory, not the direction that Friedman is defending himself in. So economists use something which you can apply for negligibility assumptions. They use it to defend domain assumptions which are false. Okay. And they present students as if they're heuristic. They say, oh, look, you might object to that, but we remove it in later theory. Well, you take a look at later theory, and you find the so-called restricted assumptions that you get in first year are even worse when you get to the more advanced theories. And somebody who's been through the experience of it is nodding his head very vigorously here. So what you've got is, I mentioned another paper there on philosophy of science by a guy called Lakatos, and has anybody here read Thomas Kuhn? You've heard of Thomas Kuhn?
Read the first 3 chapters
Pardon?
this morning.
Read it yesterday.
Read it this morning.
Yeah, highly worth reading. I think it's one of the most brilliant books ever written, called The Structure of Scientific Revolutions. And in the case of Kuhn, what Kuhn was trying to do was to apply Popper's philosophy of science to explain the evolution of astronomy over time. So back to the Ptolemaic astronomers, what Popper argued was that scientists come up with bold conjectures to explain some thing they see in the sky, and that's a myth. So first of all, you presume there's some god dragging the sun around in the sky to explain the motion. If you come up with this mythical explanation, you then try to destroy it. Okay, so you come up with a bold conjecture, and then as a scientist, rather than a religious person, you try to destroy that conjecture and come up with a better theory. And each time you do it, you get a better and better theory, and over time you move from myth to science. So Kuhn, as a historian of science, tried to apply that to understand the progression from Ptolemy's theory to Copernicus's theory, and he looked at what the Ptolemaic astronomers were doing, and it was highly scientific in the sense that there was lots of observations of data, fitting the data to a model, modifying the model so it fitted the data better over time, and he could not call those people as believers in a myth. They had a paradigm, he said, the paradigm being that the Earth's the centre of the universe and all motion is in circles around it, but it was extremely complicated work, and it took sophistication. And what he saw instead, they were defending a paradigm, a belief system. And along comes a rival belief system, which is the idea the sun is the centre of the universe, with a different explanation. And that's how he saw science as progressing. You go from a paradigm which is pushed to the point where it reaches some fundamental contradiction that it can't resolve, and then another solution will come from people outside that paradigm, and you get a scientific revolution. So it's called the structure of scientific revolutions. Lakatos embellished that by saying that there's not just one paradigm, there'll be a range of competing paradigms, and the paradigms will have a hard core of beliefs you can't challenge, and a protective belt of stuff you're willing to adjust to defend the hard core. So the theory of the diminishing marginal productivity, therefore rising marginal cost, is part of the hard core of neoclassical economics. And they're defending it in numerous ways. One is by ignoring the data, okay? And the other is by adjusting it to have things like imperfect competition as well as perfect competition and so on to keep this core paradigm alive. So that's talking in terms of the supply curve. What I'll do with you next week is go through the demand curve, which is even worse as it happens, because the funny thing is what I've done here with talking about the supply curve is I'm bringing in mainly non-orthodox economists who are critiquing it for decades. The first critique empirically was done by, logically was done by Schrafer in 1926. The first empirical work to contradict it was done in the 1930s. But the demand curve, the neoclassicals themselves actually contradicted it. Okay? It's what you might call an own goal in soccer. And the way they've handled that own goal is quite informative. So that'll do. I jumped over some stuff. Shall I go back to the stuff I jumped over, which was about why they use some particular cost functions? I'm sorry about that. I've been because I got asked to do this lecture, or this set of lectures very suddenly with Engelbert's resignation. I've been putting stuff together very rapidly, and I think I've managed to put some stuff out of sequence. So what I talk about is what the actual production is like, and then what their model is like, and why they use a particular mathematical form. So if you look what's going on in producing any particular commodity, there's lots of goods being used to produce one particular commodity. Lots of inputs, one output. And you combine them using machines and labour, and you're exploiting free energy as well. If you don't exploit energy, you don't produce anything. And you're necessarily producing waste as well. That's the general world in which we live. And there's lots of feedback. So you've got free energy coming in, you've got other goods coming out, you've got depreciation occurring, consumption is occurring a small part of it, you've got to have intermediate goods as well to produce anything, and then at the same time you've got innovation changing what's being produced, and you've got waste. All that's really got to be tied together to understand it. And what's called the laws of thermodynamics, I'll talk a bit about that in the other course. Who's heard of the laws of thermodynamics? Who hasn't heard of the laws of thermodynamics? Yep, okay, that's the world we live in. There's a wonderful book by a guy called C.P. Snow called, I think it's called The Two Cultures. And C.P. Snow was a physicist who wrote novels. So he had friends who were physicists and friends who were novelists and playwrights and so on. And he said the novelist would disparage the scientists as being uncultured people who haven't read Hamlet and stuff like that. And he'd say to you, well, how many of you understand the laws of thermodynamics? And I'd, what's that? He said, it's more important than Hamlet. Okay? And the laws are summarized by an American poet called Allen Ginsberg. And he says, first of all, first rule is you must play the game. That's called the zeroth law. The first law is you can't win the game. The second is you can't even break even. And third is you can't leave the game. Now that should be the essence, that should be the starting point of economics, and I'll come back to why it is in the other lecture course, but that's the real world we live in, which economic theory of production almost completely leaves out. You don't get any real feedback going on. You get labour and capital coming in and goods coming out. Okay? You have labour and capital and goods. Now that's not just neoclassical theory that makes that mistake. Post Keynesian also does it. Okay? The only group that had actually done some serious work about this is what's called Sraffian economics, or the Nobel Prize winner Vasily Leontiev with input-output analysis. But you need goods to produce goods. Okay? It's an input-output process, not as, from labour and capital to goods. Goods are being used to produce goods along with labour and along with energy. So the neoclassical, that's the signature, the thing that distinguishes them is the saying you can smoothly substitute labour and capital for each other. So if you have a decline in output because of labour, you can compensate by more machines and vice versa, and diminishing returns, which I've been through rubbishing here to those so-called factors of production. So you get a diminishing rate of output from an increasing level of input. And that's an essential part of their assumption. And they say marginal product, the factor, equals its income. So if you're working in Tesco's as a part-time job to pay for your accommodation in London, you're being paid £10 an hour. The argument is that £10 an hour is the marginal contribution to output of the last person being hired. So you're getting rewarded essentially for your contribution to production. And that's why Rupert Murdoch earns so much. Okay. So the marginal product of labour is supposed to be equal to the real wage, and the marginal product of capital is supposed to be equal to the rate of profit. That's the theory of distribution. They have what they call a meritocratic theory. You get paid, in effect, for the contribution your particular type of factor of production is making to output. So it's a meritocratic theory of income distribution. Now, if they have diminishing marginal product as well, and I've shown you that in the other part of the lecture, then you're going to get rising marginal cost. And the idea is you're adding a variable input like labour, which is the main variable input they look at in their models, to a fixed factor called capital. So output rises but at a diminishing rate. You're paying a constant rate for the inputs. You're not presuming there's any increase in wages because you're hiring more workers. And you get rising marginal cost because of diminishing marginal productivity. So this is, I'll put this up elsewhere in the lectures when I put the slides up on the screen, but the basic idea is you have a fixed capital of six jackhammers, one worker. So you hire one worker and he operates all 6 jackhammers at once. Okay, which is sheer nonsense. You finally get to the ideal ratio, 1 worker per jackhammer, and then you want to dig more holes. You've got to have more than 1 worker per jackhammer, all of which is nonsense, of course. I want to get onto a reason why they use a particular equation, though, because I'll be talking about this in a couple of weeks' time. So you get this idea of rising productivity for a while, then diminishing marginal productivity over time. And that's their constant refrain. The equation they use, this is what I wanted to get to, this is what they call the Cobb-Douglas production function. Quantity produced is they normally use capital A there rather than alpha. This is an old set of notes I had to work, I'll have to go back and edit them in a moment. That's what they call total factor productivity. Multiply labour raised to a power of beta, multiply capital 1 minus beta. Now the reason they have alpha and beta and 1 minus beta here is what they're arguing. If you double all inputs and double all labour and double the capital, you get double the output, constant returns to scale. That's a reasonably valid assumption. But that's the equation they like. And the reason they like it, it tells you quantity produced as a factor of the technology times the number of workers, with beta saying how much productivity can be given to workers versus capital, and the amount of machinery as well. That's their favourite equation. And I want to show why they like it, because as it actually happens, it fits the data really well because it's simply regressing 1 against 1. I'll explain that if you take a look at some of the papers by McCombie and Shape, you'll see that. But if you take the equation and use alpha as 10, so that's your total factor productivity, 100 machines, beta equal to 0.4, and you vary the number of labour workers between 0 and 250, then there's diminishing marginal productivity. Okay? That's what they want. They want that shape. And if you have 100 workers, you're going to produce 1,000 units of output. If you go to 250 workers, you produce 1,443 units. See, that's your marginal productivity for the extra 250 workers. So each worker is adding more to output, but at a diminishing rate, and that's why they like this particular equation so much. Now, if you differentiate it with respect to labour, this is where the marginal productive stuff comes in. So what they say is there's total product. The rate of change of that respect to labour is the marginal product of labour, and that, what you're doing is simple calculus here. How's your calculus?
Yeah.
You know, pardon?
Well, I don't get it.
You don't get it?
No, could you explain it again, please?
Okay. If you have a function like this, you're saying there's quantity being produced. Okay. And you're saying what is the rate of change of quantity with respect to change in labour? And what you've got here is like having x squared. You say y is equal to x squared. So you differentiate y with respect to x squared, and you get it's going to be y dy dx is equal to 2 times x. So what you've got is this is going to be, if this was 2, that'd be 2 minus 1. So when you differentiate, you have a -1 here, and you bring the beta out the front. Okay, that's the basic differentiation, very simple differentiation. What you're now saying is the rate of change of output with respect to labour, we call it the marginal product of labour, and that is going to be diminishing because this is going to be a negative now because beta is less than 1. So it's the marginal product of labour is going to be equal to beta multiplied by this divided by labour. That's beta multiplied by the output per worker. And output per worker is going to diminish as you increase the number of workers. That gives you diminishing marginal productivity. If you're paying the same wage for the workers, you're going to get rising marginal cost. That's the reason they like the equation so much. So marginal cost rises with that particular function. That's why they're so fond of it. And then that's the marginal cost is then going to be the wage rate multiplied by the inverse of this. So they're multiplying upside down. So marginal cost is necessarily rising because this LQ ratio will rise, more workers to produce output as the level of output rises. That's why they like the equation so much. And you'll see in all the neoclassical models, they use what they call a Cobb-Douglas production function. So if you graph this, and I'll put it all just quickly over here on the other screen, what you have there is the marginal product, diminishing product per worker. So you start with a very high product and it falls. What you get out of this rising marginal cost. So that's sort of marginal product, that's total product there is rising but a diminishing rate. So marginal product is falling for the whole time. And then, again, just going through the various numerical examples here, I'll jump over that given our time. But what you then do is turn it upside down, you flip the axes. Okay. So I had output on the vertical, number of workers on the horizontal. Now I'm getting output here on the horizontal, number of workers on the vertical. You need more output. Okay. You're assuming you're paying the same price for them. Your marginal cost is going to rise. So that's why they're obsessed with the Cobb-Douglas production function. And I'll be using that a bit in future lectures. That's why I wanted to show why they love it so much. Okay. So that's a little part I missed out beforehand. So, any questions on what the hell happened in that 2 hours?
Yeah, why are neoclassical economists employed?
Pardon?
Why are neoclassical economists employed and what do they do?
That's a good question. Most firms think they need an economist to work out marketing fundamentally. And what will happen is they get employed, and often most of the work in the finance sector, most economists actually end up working for the public sector, which I find quite ironic because they're spending their time working in the public sector trying to destroy the public sector. And they've done a pretty good job. So most of them work in, if they work formally as an economist, you'll work for Treasury, you'll work for the central bank, you'll work in the Competition Commission, etc., etc. And you think you're making capitalism better, but you're actually working from a theory which is antithetical to capitalism. Which is one reason that I argue that businessmen should be supporting non-orthodox economists to destroy this crap, because it's actually antithetical to capitalism to let this happen. But at the same time, this stuff was used to fight the socialist period. I argue socialism is really bad because it's unstable or low productivity, and they're giving an ideological defense of capitalism. That was an important function that they played. And then often when they get a job working in an actual firm, the firm will find what the hell they're on about, and so look, forget about all that stuff, we just want your numerical skills. You've learned how to run regressions, okay? You know how to use R, we might use that. So it's more a test to see you've actually got empirical skills. And the belief system is a problem, more than anything else. So, but that's a very, very good question. And I see them as being quite dangerous to capitalism in the long run. And to me, if you're going to pick out an ideology to support capitalism, what would you be focusing upon? Because what they're saying here is capitalism is efficient and gives you stability. I don't see much efficiency or stability out there. What I see is innovation. If I wanted to defend capitalism with a sound ideology, I'd be saying it's the most innovative society we've ever had, with the possible exception of early Cro-Magnon society. We first invented fire, starting fire, creating fire, taming animals, the wheel. That's pretty damn good innovation. You look what happened in the feudal period and the slave period. There wasn't a lot of innovation technically at all. Innovation has really taken off since the 1700s. So I'd be using, my ideology would be about capitalism as force creating innovation.
But would Matsukati not argue that a lot of that is done by the public sector?
Yeah, but at the same, the public sector under the Chinese, for example, shut down innovation. If you go back to the discoveries the Chinese made about gunpowder and things like that, is a feudal society. They were hundreds of years ahead of the West, and they didn't actually turn that into technological innovation. And I think Marx gives a better explanation of that, and I'll talk about this later. I'll give you one of my favourite examples because of what I see as being the difference between a feudal system and a capitalist system. In a feudal system, you're trying to produce the most ornate stuff for the ruler. In a capitalist system, you're trying to flog as much as you can to the mass market. If I was in China, I took a bunch of Australian journalists to China in 1981-82, and we got taken on a tour of the Forbidden City, and that's when they still... Has anybody been to China? Okay. The Forbidden City is the ultimate palace, and in fact there are 7 walls to get into the heart of the Forbidden City. Each of one, the further you get in with your arm, the more you realise you're surrounded. Okay? So it was designed to intimidate and show that this was the centre of the universe. But in the heart of it, they still had all the original ornaments in the actual castle buildings. So one of them, my favourite, was about a 7-metre high piece of jade, which had been carved in the shape of a jade mine. That was my favourite. But on the wall at one point, there was this huge object looking like this. Imagine my forearm, like so, with diamonds and rubies and emeralds here like you've never seen before, made of solid gold. And one of the journalists came up to me and said, "What do you think it is, Steve?" And I said, "Oh, it's obvious, it's a back scratcher." Ha ha ha. I walked in for a while, she caught up and said, "Steve, I asked, it is a back scratcher." Okay? So what you go for is the most ornate, elaborate thing. You're not trying to produce to a mass market. Now what is a back scratcher in modern society? It's a piece of plastic. You buy it for $2, it's probably made for 10 cents. So in that sense, capitalism gives you a reason to innovate for a mass market, whereas feudalism, it was about the power and anything that threatened the power of the leader would be a reason to oppose it potentially. So if you had merchants producing more innovative technology and more power, that would increase the power of the merchant, and often the response of the ruler would be to suppress the merchant in some simple way like murdering him. So in that sense, capitalism does liberate that innovation. Okay? So I would make a defence on the basis of innovation, but they made a defence on the basis of equilibrium. And if you look back and read Smith, you'll see that you can read Smith as if the champion of capitalism in the dying stages of feudalism. And a large part of what he was arguing was that feudalism gives you a defined place in society, but people were saying, well, if you get rid of that, how do we know what to do? And what he was fundamentally saying was, look, the rigid order of feudalism will be replaced by the equilibrium of the market. Okay? And so you get this idea of equilibrium being put across as an essential, but it's not. Capitalism is anything but an equilibrium system. With that equilibrium stuck in their minds, Neoclassical economists have continued working in an equilibrium way. But if you read the original founders of Neoclassical economics, they were saying, we want our successors to do dynamics. Now they think, did you suffer through doing DSGE models?
No, not really.
Lucky
we
you.
did things like the diamond coconut model.
Huh?
The diamond coconut model.
Diamond coconut? Oh,
Yeah.
you're kidding. The diamonds and coconuts on an island.
Yeah, coconuts. Yeah, diamond's model of coconuts.
Mm.
Where people trade coconuts, identical coconuts.
Yeah, it's a barter model. Again, it's a barter model of capitalism, so I'll talk more about that when I get onto the Post Keynesian stuff as well in the course. But yeah, so I think what we've got is an accidental ideology, which is a false ideology of capitalism. But it became a huge part of the defence of capitalism against feudalism, and then it became, when you were fighting the socialist system, again, it was part of that defence, and also it's anti-union. Okay? So a large part of a working class versus capitalist battle over distribution, this theory fitted perfectly into that by saying there shouldn't be trade unions. You know, we get the best situation when workers are competing with each other, and the firms are competing for the workers. So it played an ideological role as that as well. But I think a major part of it too is that it gives you when you learn this stuff and you swallow it at school, which I did when I learned it when I was 17, 16 years old, it's a vision of a perfect society. It's a vision of a world in which you'd have no power, power's completely dispersed, everybody gets what they deserve, okay? And there's no exploitation. And we are, as a species, we are attracted to the idea of an ideal world. That's why people stand on street corners selling you copies of Jehovah's Witness books, because they think this is the ideal society and they want you to join it. And I had a classic experience of that. I set up a neoclassical economist once to be torn apart by the workers and the management of the food industry in Australia. And this is when I was part of a government body called, Australia had what they called the Accord, which was an attempt by the then Labor Party to bring about a collective management of Australian economy, a bit like the Elferschreit system in Germany, which I presume Austria may have a similar thing for. There were workers' boards, as well as workers' representatives on the boards of companies, as well as just the shareholders. And anyway, the food industry asked me to bring along a person of what's called the Industries Assistance Commission, which they called the Industries Assassination Commission, and which is now called the Productivity Commission. I had the guy come along who calculated what he called effective rates of tariffs. And the whole role that the Productivity Commission did was to say, well, this industry's got, say 100% tariff, and this one has, the average is 50%. Go through this long, complicated, very detailed examination of the industry, work out there's no reason why it should have a higher level, so reduce it to the average and move on to the next industry. Now the end result of that process is zero tariffs. That was their objective. And this guy came along, gave his talk, and he was savaged by the workers and by the management, just attacked like crazy. And then we went out, the place that we held that was a country. This is pre-internet and pre-mobile phones, so he couldn't get away. And we go to the bar afterwards and he said, look, you're an economist, help me convert these people. And they really become zealots about their vision of how society should be. So it's beyond, it's not a science in that sense, it's a zealotry. That's my answer for it. Anything else? Okay, well notice that next week I've got the first reading in dark there. Please read that. We've done it, but please, you have to read that because you could be grabbed and asked to do a presentation on it.